Your Electron app ships a 200 megabit Chromium runtime to display a menu bar. Vercel Labs thinks that's embarrassing. Native SDK v0.5 lets you write TypeScript, compiles it to Zig at build time, and ships a binary under 6 megabytes with no JS engine, no garbage collector, no web view. Let's talk about whether that trade is actually worth making. 2 releases dropped in quick succession. v0.5 on July 13th introduced TypeScript authoring as the default path. You scaffold a project, write your application core in TypeScript, and the build step runs the native SDK core transpiler, which converts that TypeScript into arena-backed Zig. The final binary carries none of the TypeScript runtime. No v8, no bun, no WebView wrapper, just compiled native code. The release notes cite roughly 83 nanoseconds for update dispatch, and that figure is corroborated by the maintainer on record. Then v0.5.3 landed July 17th with 3 meaningful additions: a media surface element for cross-thread RGBA producers, think video frames or camera feeds handed off between threads, macOS trackpad pinch gesture support, and improved CJK glyph rendering for dense character sets. The session journal also bumped to version 5, which matters for the automation story I'll get to in a moment. The core design decision here is worth unpacking because it's not just a packaging trick. Traditional web shell desktop frameworks bundle a browser engine and a JavaScript runtime. Your app logic runs inside that engine at runtime. Native SDK inverts this. The TypeScript you write is an authoring surface, not a runtime target. The transpiler walks your TypeScript core and emits Zig, which compiles to a native binary. The programming model is a strict event, message, update, view loop, functional in style, no shared mutable state across threads. That constraint is what makes the deterministic session journal possible. Every state transition is logged, which means you can snapshot, replay, and drive the application programmatically. The docs describe this as supporting agent-based snapshots and input handling, which is a polite way of saying this thing was designed with AI automation in mind from the start, not bolted on afterward. One community member shipped a native email client and reported approximately 150 megabytes of RAM usage. That's a medium confidence data point from a single X post. So treat it as directionally interesting rather than a benchmark. The official docs claim under 100 milliseconds to first frame and binaries in the 3.4 to 5.7 megabyte range. Sourced third-party head-to-heads are thin here. The brief's competitive landscape is empty, and I'm not going to invent a shortlist from memory. What the brief does give us is the implicit comparison baked into the project's own framing. Web shell architectures, the pattern where you embed a browser engine to host your UI, versus transpiled native, where the browser never enters the picture. The SDK docs explicitly call out 0 embedded browsers and 0 script engines as design goals. The migration cost question is real. If you're on a web shell stack today, you're not porting your React components. You're rewriting UI in native SDK's own markup language and restructuring your logic to fit the event MSG update view loop. That's a meaningful rewrite, not a drop-in swap. The third-party component ecosystem is also an open question. The brief flags it explicitly, and I'd want to see that ecosystem mature before betting a production app on it. You should care if you're shipping a desktop utility where cold start time and memory footprint are user-visible problems. Think menu bar tools, local AI agent interfaces, developer tooling, anything where a 200 millisecond cold start and a lean process list actually matter to your users. You should also care if you're building something that needs to be driven programmatically. The session journal and automation server make this genuinely interesting for agent-controlled UIs. You should probably wait if your team's entire UI skill set is in web component libraries, if you need a rich third-party ecosystem today, or if you're shipping to mobile as a primary target. iOS and Android support is explicitly experimental, and if your app is already fast enough and your users aren't complaining about memory, the migration cost almost certainly isn't justified yet. My read: watch with a focused spike. Don't migrate anything. But if you have a desktop tool in the backlog, something small, internal, or a new greenfield utility, this is worth a one-day prototype. Specifically, I'd want to answer 3 questions before going further. First, what does the debugging experience look like when your TypeScript logic misbehaves after transpilation? The source maps and tooling story here is genuinely unknown from the brief. Second, how painful is the UI markup rewrite relative to what you're used to? And third, how active is the third-party component ecosystem right now? If those answers come back reasonable, this moves from watch to pilot. If the debugging story is rough, you're looking at a framework that's fast in production and painful in development. And that's a trade-off most teams won't accept. Vercel Labs' native SDK v0.5 is a genuinely different architectural bet. Not a faster Electron, but a different category of tool entirely. The TypeScript to Zig transpilation path lowers the entry cost significantly compared to writing Zig by hand, and the deterministic session journal is an underrated feature if you're thinking about AI-driven interfaces. The open questions around debugging, ecosystem, and mobile maturity are real, and they're the reason this stays in watch territory for most teams right now. Links to the release notes and docs are in the description. If you've already shipped something with this SDK, I want to hear about your debugging experience. Drop it in the comments.